to the lab, chemist. All right, now we are going to test the density of our unknown metal. By testing density, we can usually kind of tell what metal it is pretty quickly, but we're also going to delve deeper into that study and test the specific heat, and we'll get to that in a moment. First, we have to get the density. How do we do that? We're going to start at filling our graduated cylinder to 50 milliliters. Then we're going to add our unknown metal to it to see what the difference is. All right, so it went from 50 milliliters to around 59, I would say, 59 milliliters. So take that difference and you can use the milliliters. Remember, density is mass divided by volume in liters. So, wait. All right, now that we have the density of our aluminum, we can find the mass of our aluminum. I went over there and I dried it in the water. And now we're going to come over here and I'm going to just pour it into a... Okay. And we're sitting at 24.95 grams of aluminum. Now we're going to take this aluminum and we're going to start bringing it up to a boil. So, well, not the aluminum itself, but into a water bath. So what is a water bath? So here we have our setup. We have a hot plate. We have a 400 milliliter beaker full of water. Then we have a test tube along with a thermometer. So what we're going to see is we're going to dump our aluminum into this test tube precariously. Did I win? I won. Yeah, good job. All right, so now we're going to bring this up to a boil. What's going to happen is that energy from the water, as it heats up, will be transferred to the aluminum metal and heat up the metal as well. This does this without actually adding any more mass to it with the water. And then after we've brought it up to a boil and let it boil for about 10 minutes, we're going to transfer this to a calorimeter. Now, a calorimeter is basically your standard coffee cup. So once we do that, we will see how the water heats up with the metal and how fast it does that. Well, basically how much it does that. And we can use that value of the heat rising in the water to determine the specific heat of the metal. Okay, so now that we have let our metal boil for about 10 minutes, bringing it up to temperature, we know at this moment we're going to assume that the temperature is equal to the temperature of the boiling water. Oh, shoot. So it is around 99 degrees Celsius. I don't think it's going to stay up there anymore. Stay. Yeah, good job. Good boy. All right. So now we are going to transfer our metal to our calorimeter. In this calorimeter, I have 50 milliliters of distilled water. It's very important that you know how many milliliters of water are in here so we know how many milliliters are we changing the temperature of. Now, we need to take the beginning temperature. We're going to let that sit for just a moment. Hopefully it actually equals out. I should have done this before. That's fine. You guys got all the day in the world, right? Let's see here. Okay, so we're sitting at 23 degrees Celsius for our okay, 23 degrees. So we're going to transfer this quickly. No, don't get stuck. Yeah, not supposed to do that. That's fine. All right. So now we're starting at 22 degrees. We're going to transfer this. And we're going to see how much it changes. Right now it's sitting at 30. So we're seeing a change of right now 8 degrees. So let's give it some more time. This is supposed to be easier, better. Hopefully this one worked out. We're equalizing it. Okay, I think we're equalizing at 30 degrees, so we're seeing a change of 8 degrees Celsius. Now, using that, I think we could probably find the specific heat. Now, it may not be exact, so I would say rely really heavily on either this video or the density that you calculate to find your unknown metal.